Swayam Prabha, free DTH channel for education.
Good morning, everyone. So in today's class, we are going to talk about the power series solution for the linear ODE. Okay, so before that, we will see what is series and then we will discuss about that. So we are going to talk about the power series and how that is going to help us to solve the second order linear ODE. Okay, so that's what we are going to do. So before that, I will just explain what is the series and sequence. So first, you need to know like what is sequence. You might have studied in your school days or in your P.Tech level courses, calculus course, for example. So you can see that A1 plus A1, A2, A3, these are all numbers. Okay. So these are all numbers I have. So these numbers, we call it as a sequence. Okay, sequence of numbers I have. Now what I can do is that whether this sequence is convergent or not. Okay, so I have a sequence of number which I have arranged. So this sequence you might know like the definition of the convergence you might know. So limit n tends to infinity. Okay, an equal to n. So if this such a L is going to exist, then we say that the sequence is converging. If such a L is not going to exist, okay, suppose such a unique L is not going to exist, then we say that the sequence is going to be divergent. Now what I have numbers. These are all numbers, right? So I can add these numbers. A1 plus A2 I can find, A2 plus A3 I can, A1 plus A2 plus A3 I can find, A1 plus A2 plus A3 plus A4 I can find. So something similar to that. So let us say I can calculate this one. A1 plus A2 plus A3 plus etc. I can calculate an plus etc. So this I denote it as summation an. Okay, n equal to 1 to infinity. So this is called a series. Okay, so this I am just summing it up. This is called series. Now the question is when this is going to be convergent. Okay, when this is going to be convergent. So in that case, once again, what we are going to do is that we are going to define something as follows. So I'm going to define Sn of x. Okay, so Sn is going to be, I'm just going to define like Sn equal to a1 plus a2 plus a3 etc. an is going to be there. Therefore, it is going to be a finite number. Okay, this is a finite sum. a1 plus a2 plus a3 is a finite sum. So if it is a finite sum, then what for each Sn, for each n, I'm going to get a sequence once again. S1, S2, etc. Sn is going to be there. So I can apply the same definition whatever I have here. So in that case, what I can do, I can just define that limit n tends to infinity Sn equal to n. Okay. So suppose this L is going to be existing, then we say that this series is convergent. Okay. Suppose such L is going to exist, then this sequence is going to come. This sequence is called sequence of partial sums. If this sequence of partial sum is going to converge, then we say that this series is going to be convergent. Okay, that's what we have. Now what we are having is that we have how to identify whether it is going to be convergent or not. So for this, some of the theorems are available. So we are going to, I'm just going to say only two tests. One is ratio test, another is root test. So for ratio test, what is it going to say is that n tends to infinity, okay, limit n tends to infinity, an plus 1 by an modulus, okay, is equal to n. Okay, suppose this is equal to n. And this L is less than 1, then I say that this series is convergent. Okay, the sequence of partial sum is convergent, and hence this is going to be convergent. If it is greater than 1, okay, then we say that this is a divergent series. Okay, this is going to be divergent. If it is equal to 1, I can't say anything. I can't conclude anything. Okay, it may be divergent, it may not be convergent. So I can't conclude anything from it. Similarly, if I have a limit n tends to infinity, okay, an plus 1, sorry, not an plus 1, we are going for the root test. So for root test, what I have, nth root of an, okay. So this also I called as root test. This is called ratio test, okay. This is called ratio test, and this is called root test, okay. So using this test, what I can say, again, this suppose this L, if it is less than 1, then I say that it is convergent. If it is greater than 1, I say it is divergent. If it is equal to 1, I can't say anything about it. Okay, I can't conclude anything. Okay, so this is the one which we have for the sequences and series. Now what we are going to do is that, so I explained what is series. There is a term series in the power series, so I explained series, what is series. Now what we are going to see is that we are going to see the power series. Okay, power series. So power series of this form. So you might have here Taylor series already. Taylor series is of this form, like you might know, like suppose f of x is given, f is given, and then you used to find that something like fn of x, okay, fn of x naught divided by n factorial into x minus x naught whole power n. This might have studied in the calculus course also, Taylor series. Now power series, what is power series is almost similar kind of thing, but here what we are going to have is that we are going to have something like this, okay, we are going to have like I'm going to write it like this way, summation am into x minus x naught whole power n, okay, m equal to 0 to infinity, I'm going to write, okay, almost similar kind of things here, the Taylor series also. So summation am into x minus x naught whole power m is there. So this is having the powers x minus x naught, these are in powers, and it is again a series, therefore it is called power series, okay, because I have x minus x naught whole power m, means everywhere I have a power, okay, power is there, that's the reason I am going to call it as a power series, okay. So this series is called, this infinite series is called a power series. Here x naught is fixed, okay, am is constant, means each am is constant, okay, and x is a variable, this is the variable, okay. So this is the variable. So these are the things I have, and this x naught is called the center of the series. This x naught is called the center of the series for this power series, okay. And ams are constant, and x is also a x naught is a fixed number, and x is a variable. Now what we have, we are going to talk about once again the same kind of setup, okay. So we are going to talk about the same kind of setup. Now whether this series, again I said it is a series, so we got to check whether this series is going to be convergent or not, etc. We got to see, okay. So now what I'm going to see is that I'm going to calculate, for example, I'm just going to fix a x1, okay. Remember that this is not a number, okay, this is not a number, this is a function, this is going to become like a function, it is going to be a function of x, okay. If it is convergent, suppose it is convergent, I'm going to get it's a function of x is going to come, because here I have a variable, therefore it is not going to be a number, it is going to be a function of x is going to be there. Now suppose I fix a x1, okay, let us fix an x1, okay, assume that some x1 is fixed, then what I am going to find, I am going to find whether summation m equal to 0 to infinity am into x1 minus x naught power m, we are going to check. Now this is going to be as something similar to that, because am is constant, x1 I have already fixed, therefore x1 minus x naught is going to be a number, and I am raising a power, therefore almost similar to whatever I have here. Only difference is here m equal to 0, here n equal to 1. That's the only difference. Otherwise, almost same thing is there. So therefore, it is a series. Okay, it is a series of number. Okay, it is a series. It's a sequence of number. So it is a series. Okay, the series is written in terms of the numbers only. No function is there as it is here. Okay, so only numbers are going there. Then I got to check the same kind of logic whether it is going to be convergent or not. Then once again I have to do the same thing. So I'm going to define Sn of x. Okay, Sn of x is going to Sn of x1. Okay, Sn of x1 is going to become like a naught. Okay, because m equal to 0, this is going to become 1. Okay, this term is going to become 1, and it is going to be a1. A naught. Then a1 into x minus x1 minus x naught plus a2 into x1 minus x naught whole square plus etc. is there, plus an into x minus x naught whole power n is there. So this is what I have. S1 of x1 equal to this one. Now what I am going to do, so this is number, right? So this is x1 minus x0. So this is a number, right? So since it is a number, what I am going to see whether this is going to be convergent or not. So therefore what I am going to have, I am going to have S0 of x1 is going to be there, S1 of x1 is going to be there, S2 of x1 is going to be there, etc. is going to be there. So this is a number I am having. This number what I am going to have is that I am going to check again the same thing. Limit n tends to infinity Sn of x1 equal to suppose n. Okay, suppose such a L is existing, then I can say that this sequence of partial sum is going to be convergent. Since this sequence of partial sum is going to converge, this series is going to converge. Okay, so that's what we are going to say. Now I have one more thing here. So I have something called Rn of x. Okay, Rn of x I can define. So Sn of x means is going to be there. Rn of x1 also I can define in a similar way. Okay, Rn of x also I can define. Okay, so that is going to be the remainder term. Okay, that is going to be, I call it as a remainder term. So that is nothing but, so let us say like Rn of x I'm defining. So an plus 1 into x minus x naught whole power n plus 1 plus n plus 2 into x minus x naught whole power n plus 2 plus etc. is there. Okay, this is called the remainder term. Okay, Sn of x1, Rn of x is there. So now what I have, I'm going to see what all the things are available. So as I said here, so this is convergent etc. is there that we have discussed. So if this is convergent, then we can say this series is going to converge. So if it is not convergent, if at x1 is not going to converge, then we say that these are divergent. So that's the only thing we need to see. Now what I'm going to have, so this I have already explained here, so that is given here. Now what I'm going to say, some of the remarks, let us observe some of the remarks. Suppose wherever this x1 is going to converge, I cannot guarantee a priori, but at one point it is going to converge, because if we put x equal to x naught, what it is going to come, at x equal to x naught, I'm going to get only a naught term is going to be there. A naught going to be definitely there. Other than that, I don't know, because x naught if I'm putting, so here everything is 0, a naught will be there. Remaining term will become 0. Now for other than x naught, I don't know whether it is going to convergent or not. That we are going to discuss a little later. So in this case, definitely the series is going to converge at one point. That point is x naught. Okay, definitely it is going to converge at the point x equal to x naught. Okay. So if there are values other than that x naught, suppose other than that x naught, suppose some values are there, then it is not going to be a only thing in that place. Okay, it is not left alone. There will be infinitely many numbers is going to be there. Means it is going to form an interval. Okay? If it is other than x naught, suppose some variables are there, then you can immediately conclude that there is an interval, small interval is going to come. In that interval, definitely it is going to converge. Okay, so that interval is called the interval of convergence. Wherever that series is going to converge, that is going to form a small interval. That interval is called interval of convergence. Okay, and since I said it is an interval, okay, so therefore I can write that interval as, let us say, I equal to x minus x naught, okay, which is going to be less than r. This r I call it as the radius of convergence. Okay, if it is less than this one, then I call it as that r as the radius of convergence. So apart from this r, okay, apart from this interval, it is going to converge. Okay, with less than r, it is going to be convergent. Greater than r, it is going to be divergent. Okay, and this r is called the radius of convergence. If it is converged everywhere in the real number, if it is converged for all x in the real number, then we say that r equal to infinity. Okay, these are all some of the quick remark we can make it. Now, where is it going to converge? Now we have here we have the ratio test, right? Here we have the ratio test and root test. The same kind of things we are going to derive for here also. What we are going to do is that we are going to see a similar kind of ratio test I am going to apply. So in that case, what I can do, I'm just going to apply that limit n tends to infinity. Okay, I'm going to apply that. So here, what is that one? Which is nothing but an plus 1 into x minus x naught whole power n plus 1 divided by an into x minus x naught whole power n is there. Okay, modulus. Therefore, this is going to become like, I can write it as limit n tends to infinity an plus 1 divided by an into x minus x naught. Okay, because n cancels, so x minus x naught is going to come. Now, suppose this is going to be r. Okay, suppose this is the interval where I have, it is going to be less than r. Okay, if it is less than r. Okay, so suppose this x minus x naught is less than r, then what I am going to have? I am going to have something like limit n tends to infinity. Okay, an plus 1 by an into this is x minus x naught less than r. Therefore, this is going to become like, I can write it as this less than r equal to into r. Okay, so this is going to be less than r equal to actually. This is going to be less than actually, strictly less than, because I have left less than 1. So it is going to be strictly less than limit n tends to infinity an plus 1 by an into r is going to come. Now what I have, so this r I have, suppose, now if you see this one, suppose this is going to be n. Okay, suppose this is going to be l. This is going to be l into r is going to come. Okay, suppose this is going to be l into r. Okay, so in that case, what I am going to say, when it is going to converge or not converge. Okay, so if it is going to be like l is less than 1, if l is less than 1, then I am going to get this convergence is going to come. Therefore, what I am going to have, I am going to have something like r is going to come. So in that case, suppose this is less than 1, then what I can say is that this is going to be like the total quantity is less than 1. Then I can say that my 1 by r, okay, which is nothing but the r is nothing but the radius of convergence, limit n tends to infinity 1 by r. Okay, so because I'm just going to less than 1, so I'm going to bring it in this side. So limit n tends to infinity an plus 1 divided by an. This I call as the radius of convergence. Okay, so this I call as the radius of convergence. Limit n tends to infinity an plus 1 by an. So immediately from that one also I can observe the similar kind of thing. Okay, so in that case, what I'm going to have similar kind of thing. So 1 by r equal to limit n tends to infinity. Okay, nth root of an is going to come, because you are going to take the same kind of logic over there. X minus x naught 10 power n is there, so n will get cancelled. So same kind of logic is going to go. So this is going to be 1 by r limit nth root of n a is going to be there modulus a n. Okay, so I forgot to put modulus here. That's a modulus. Okay. So there is a modulus there, so you should be remember that there is a modulus. Okay, because if you take square root of a negative number, it will not come, because I didn't say anything about the a1, a2, etc. So it should be very careful. A should be positive. So limit n tends to infinity, nth root of mod a should be. Okay, so that is something. Okay. So this is the formula given. 1 by r is equal to limit n tends to infinity, a n plus 1 by a n, which is going to give me the answer about the radius of convergence. So we will see some of the problems and then see what is the radius of convergence is going to be obtained for those problems. Okay, so I have 3 problems are there. So let us see and then go for the solving the problems. Okay, so how to solve it. And we have to discuss about whether if I have a power series, whether we can sum it up or subtract it or multiply that or differentiate that, those things we will discuss. Okay. So now let us see 2-3 problems. An interval of convergence for the following power series with some examples. First problem, let us see a summation of m equal to 0 to t m plus 1 into x power m into x power m. Okay. So I need to calculate the radius of convergence. So let us calculate 1 by r. 1 by r is nothing but limit m tends to infinity. Okay, m tends to infinity, am plus 1 divided by am. Okay, this is the way to find the radius of convergence. Okay, so am plus 1 equal to so you can calculate this one. So limit m tends to infinity, m tends to infinity. Am plus 1 is nothing but m plus 1 into m divided by. So am plus 1 is there. So wherever m is there, you got to replace with m plus 1. So therefore, this is going to become like am plus 2. This is going to become like m plus 1. Okay, and divided by m plus 1 into m is going to come. So m plus 1 get cancelled, and I'm going to get limit m tends to infinity, m plus 2 divided by m. Okay, so this is nothing but limit m tends to infinity. I can write it as 1 plus 2 by m. So m tends to infinity, this is going to become 0. Therefore, this is going to become 1. Therefore, 1 by r is going to become like 1. Okay, and I is going to be, which implies r is equal to 1. Therefore, I is going to become like minus 1 comma 1 is going to be. Okay, so this is the interval of convergence. Now let us go for the next one. So in this problem, simply I am having only x power m. So I can just replace this one. Okay, so I'm just going to rewrite over here. So this is going to become like x power m. So this is same. So this can be replaced. So this is going to become like limit m tends to be a plus 1 is also 1, a is also 1, so 1 by 1 is going to come. Therefore, this is going to become 1, so 1 by r is going to become 1, r equal to 1, I equal to minus 1 comma 1. Okay, so we'll consider minus 1 power m by m, x power m problem. So in this case, what is it going to become? Limit m tends to infinity. This is going to become like minus 1 power m plus 1, okay, divided by m plus 1 into. Okay, so this is going to become like m divided by minus 1 power m is going to come. Okay, so limit m tends to infinity as it is. So this is going to become like I can write as limit m tends to infinity. So minus 1 power minus is going to be there. So this is modulus, so that is going to be go out. So m divided by m plus 1 is going to come. So I'm going to replace this as m plus 1 divided by m plus 1 minus m plus 1. Okay, so this one I'm going to write it. So this is going to become like 1 minus 1 by m plus 1 is going to come. Okay, limit m tends to infinity. Okay, so this one I can write as 1. Okay, so therefore you can expect that 1 by r equal to 1. So r equal to 1. So minus 1 power I equal to minus 1 power minus 1 comma 1. But in this case, what is it going to happen is that, so this is not m equal to 0. This is m equal to 1 to infinity. Okay, because 1 by m is there. M equal to 0 means it is not defined. So in this case, what is it going to come? So you are going to expect that you are going to get like you are going to consider this sequence. Minus 1 power m series, okay, summation m equal to 1 to infinity, it is going to come. This is an alternating series. So what it will come is that if you substitute it over here, x equal to 1, this is going to become like minus alternating series, minus 1 power m by m is going to come. So this series, alternating series, this is converging. Okay, this series is converging. Now, note that this is not converging. Okay, this is converging. Note that this is not converging. If I substitute x equal to -1, this is going to become like 1 power minus is that, so minus 1 power m minus 1 power m. So therefore it is going to become minus 2 power m. So 1 by m is going to come. This is not converging. Whereas this series is converging. Remember that 1 by n sequence series is not, it is not converging. Whereas minus 1 power n by n, this is converging. Okay, this is going to be converging. Therefore, minus 1 comma 1, this is going to become like minus 1 closed 1. Okay, 1 is also included over here. Whereas in the case of left side, it is not included. Okay, so that you should be careful. Similarly, next problem. So 5 power m by m factorial. So 5 power m by m factorial. So in this case, it is going to become like, I can just replace it here. 5 power m plus 1 divided by m plus 1, 1 factorial, m factorial into 5 power m. Okay, so therefore this one is going to become like, this is going to become like, I can write it as limit m tends to infinity. So m plus 1, m is going to get cancelled. So it is going to become like 5 m plus 1 factorial. So this is going to become like 5 power m, 5 by m plus 1. So this is going to become 0. Okay, so therefore 1 by r is going to become 0. If 1 by r is 0, r is going to become like infinity. Okay, so that means I is going to become like minus infinity comma infinity over here. So that's what we are going to discuss. Suppose I got two series. Okay, one is summation am into x minus x naught whole power m. Okay, this is nothing but first series. And another series I got summation m equal to 0 to infinity bm into x minus x naught whole power m is going to be there. Okay, so let us say this is convergent and this convergence is positive. The radius of convergence is positive, and I call it as f of x. Okay, and this I call it as g of x. Now I got two things. Okay, f of x and g of x. This is nothing but two series I have. Now term-wise addition. How do we do the term-wise addition? Okay, suppose this is having a positive radius of convergence and this is having a positive radius of convergence, and both of the series are having a common interval of convergence. For example, I have this is also converging to minus 1 comma 1 and this is also going to minus 1 comma 1. No problem. Suppose this is going to be convergent minus 1 comma 1 and this is minus 2 comma 2. Then common interval is minus 1 comma 1. No problem. Suppose this is minus 1 comma 1 and this is having a interval like 1 comma 3. In that case, this is going to have no common interval of convergence. Okay, so therefore, in that case, you can't do that term-wise addition. So, in this case, in these two cases, you can do. In this case, you cannot do that. Okay, so for these two cases, suppose this kind of fixed, what you can do is that you can do the term-wise addition. So, how do you do? Summation m equal to 0 to infinity am plus bm into x minus x naught whole power m. Okay, this is going to be the term-wise addition. So if I define like f of x and g of x, this is going to be okay. So this series converges in the common interval of convergence. For example, here it is going to converge minus 1 comma 1. Here it is going to converge minus 1 comma 1 because the common interval is minus 1 comma 1. Okay, the intersection is going to take it. So in this place, it is going to be converged. I cannot guarantee whether this is going to converge in this place minus 2 comma 2 because this series is not going to converge. Therefore, I cannot guarantee whether it is going to converge or not. Now, term-wise multiplication. So for term-wise multiplication, what I need to collect the x minus x naught power m term. So if I take a naught term here, for example, here I can take a naught term. Then which term I got to take it here? I got to take the bm term. Okay. Then I will get a x minus x naught whole power m will come. Now if I take a1 here plus a1, then here I got to take b m minus 1. Then it will become like x minus x naught whole power m will come. Okay, because here a1 into x minus x naught, here b1 into bm minus 1 into x minus x naught whole power m minus 1. Therefore, it will become like x minus x naught power m. Similarly, I can take a2. If I take a2 here I got to take bm minus 2. Okay, etc. is going to be there. So in general, the last term is going to become like a m b naught is going to be there. So if I want any intermediate term, the intermediate term will be like bi into a into b m minus n is going to be there. So the idea is that if you sum the indices, it is going to be always m. Okay, here you can see that m. This is also m minus 1 plus 1 m, m minus 2 plus 2 m. Here also m plus 0 1 m, and this is m minus I plus m minus I. That is going to be m. So this is going to be okay. So this is called. So if these two series are convergent and that interval, then I can say that this is the term-wise multiplication where it is going to be convergent. And again, once again, you see the common interval of the convergence. Okay, only at the common interval of the integral it is. Now what I have the suppose this I write it as y of x. Okay, suppose this I write it as y of x because we are going to use this concept for our. So suppose I want to differentiate this one. So if I differentiate this one, this is going to be like a polynomial. So if it's a polynomial, then you can define this one summation m equal to 1 to infinity m into am into x minus x naught whole power m minus 1 is going to come. Okay. So you can see that if I have this one, this you can write as a naught plus a1 into x minus x naught whole power 1 plus a2 into x minus x naught whole square, etc. is going to be there. So you can see that first term is going to become like a1 x minus x naught. Okay. Second term is going to become like a2 2a2 into x minus x naught, that is going to be there. Similarly 3a3 etc. is going to come. Okay. Now suppose this is my y dash of x. Okay. Suppose y double dash of x. Suppose I define y is y double dash of x. So in that case, I can define something similar to that. Summation m equal to 2 to infinity m into m minus 1 into am into x minus x naught whole power m minus 2 is going to. Okay, this is called the. Now what we are going to do is that we are going to give another simple equivalent expression for this one. So what I am going to write is that I am going to write this as summation m equal to 0 to infinity. Okay. M plus 1 into wherever m is there, push that to m plus 1, then you will get this expression x minus x naught power m. Okay, because I want to put this variable, so m minus 1 equal to, for example, if I have m minus 1 equal to k, then I can put m equal to k plus 1. Okay, then this automatically it will become like k equal to 0 to this one. Okay, m minus 1 equal to 0 to means it is going to become like m plus 1 I can put it. Okay, k plus 1 in the place of k plus 1 and get like m plus 1. So you can verify also whether this can be true or not. So first we verify that. What is the first term here? The first term is going to be 1 into a1 into 1 into a1. That's all. Okay, 1 into a1. What is the first term here? M equal to 0. If I put m equal to 0 means 1 into a1 into this is going to be 0. Therefore, it is going to be a1 is going to be 1 into a1. Second term here, this is going to become like 2 into plus 2 into a2 into x minus x naught is going to come. Okay, x minus x naught. Let us see whether that is the same thing here. So m equal to 1 means it is going to become like 2 into okay a2 into x minus x naught is going to be there. Similarly, you can verify the remaining things also. Same thing here. Here, what I can do is that wherever, so in the place of m, what I'm going to do is that m minus 2 equal to k I can put. So m equal to k plus 2 is going to come. So wherever m is there, replace with the k plus 2 and then again reassign the k as m. Okay, so in that case means replace the k by m. So in that case, what you are going to get is that you are going to get summation m equal to 0 to infinity. Okay, m plus 2 into m plus 1 into x minus x naught a m plus 2 I got put. Okay, a m plus 2 into x minus x naught power m is going to come. Okay. Why do we need this one? Because once we are going to use this for our solving the second order linear ODE, we may need to use this. Some places maybe you need to use this formula, some places you may need to use this formula so that you get some kind of recurrence relation is going to come. So that's the reason we are going to. Now what I am going to do is that suppose I have a problem like this, y double dash plus p of x into y dash plus q of x into y equal to 0 is there. Okay. So in this case, what I am going to check is that y double dash plus p of x y dash plus q of x into y equal to 0. So in this case, I am going to check. I am going to use this one. For example, y double dash I will substitute here, and p of x into y dash I will substitute this one, and q of x into y I will substitute this one. Okay. So therefore, you are having a sum. Whereas on the right hand side I have 0. Okay, left hand side you will have a series, on the right hand side you are going to have 0. So you need to equate both sides. So in that case, what you are going to say is that we are going to have vanishing coefficient. Means after I sum it up everything, you are going to get something like some terms into x power m is going to come. Okay. So if this is equal to 0 after simplification, what you are going to get is that this term is going to become 0. Then only this is going to become 0. Okay. So that's the only thing we are going to have in the next few minutes. And we will use this concept to find the answer for this problem, okay, for this kind of problem. Okay, so that's what we are going to do. So we'll start with simple one dimensional means first order ODE, and then we'll go to the second order ODE. Okay, later. So what the last point is saying, it is vanishing coefficient. Okay, if it is 0, then each of its coefficient is going to become 0. That's what it is saying. The vanishing coefficients of it. Okay. So also one more point. So if y is having a radius of convergence r, then the y dash and y double dash also going to have the same kind of radius of convergence. So now let us solve a few problems. So there are 4 problems available. Okay, we will solve one by one. So We'll solve one by one and see how to use this formula. Okay, so that's what we are going to do. So let us start with a simple problem now. So I have the problem y dash plus y equal to 0. Okay, so immediately you can check whether what is the solution of this problem. Okay, without further delay, ty by y equal to minus dx is going to come. Okay, therefore this is going to become like ln y equal to minus x is going to come. Therefore y equal to c into e power minus x is going to become. Okay, this is going to be my solution. Let us check whether we are going to get the same thing in our using our power series solution also. So in this case, what you are going to do? You are going to take y dash. I'm going to take this y. So y is going to be summation m equal to 0 to infinity am into. I'm going to expand only at the power series around x equal to 0 only. Okay. So at that place only we are going to discuss, and where can we expect this, etc. We'll discuss later. Okay, where you need to discuss about the convergence. Okay, where it is going to be obtained. Those things we will see. So that we'll see it later. So for this problem, we are taking this is going to be the solution. Okay, we are assuming this is going to be the solution. Then y dash is going to become like summation m equal to 1 to infinity am into am into x power m minus 1 is going to come. Okay. So I can write it as summation m equal to 0 to infinity m plus 1 into am plus 1 into x power m is going to come. Now y dash plus y I got sum, therefore I am going to sum these two terms together. Therefore I am going to get sum y dash plus y is going to become like summation m equal to 0 to infinity m plus 1 into am plus 1 plus am into x power m equal to 0. So that means this should be entirely 0. If x equal to 0, it is going to happen, but x equal to 0, I am not interested because that is going to be the trivial solution. So x not equal to 0, that means this is going to become 0. Therefore, what you are going to get? You are going to get a recurrent relation. This relation is called recurrent relation. So m plus 1 into am plus 1 plus am equal to 0 is that. Okay. Therefore, you are going to get am plus 1 is going to become like minus am divided by m plus 1 is going to come. Okay. So therefore, you are going to get, for example, a1. What is a1? A1 is going to be like minus a naught by m equal to so m equal to 0 if I put. Okay, m equal to 0 means this is going to become like a1 and this is going to become like 1. So a2, when I put m equal to 1, this is going to become like a2. A2 is going to become like minus a1 divided by 2 is going to be there. Okay, that is equal to, already I know what is a1. Okay, that is going to become like minus 1 square into a0 by 2 is going to come. Okay, 2 into 1 is going to come. Now m equal to 2, you can see that a3 which is going to become like minus a2 divided by 3. Okay, it is going to become like minus 1 whole cube a0 divided by 3 into 2 into 1. Okay, similarly m equal to 3, I can see m equal to 3 is going to become like a4 equal to minus a3 by 4 equal to minus 1 power 4 a0 divided by 4 into 3 into 2 into 1 is going to. Therefore, what you are going to get is that all the terms you can expand that. So in general, you are going to get am is going to become like minus 1 power m a0 divided by this one. You can see that this is nothing but 4 factorial, this is 2 factorial, this is 3 factorial, this is 2 factorial. Therefore, here you can expect that m factorial is going to come. Okay, because here 4 factorial, a4 4 factorial, a3 3 factorial, a2 2 factorial. Therefore, am should be m factorial. Okay, therefore, what it is going to come, your y is going to become like, okay, so your y is going to become like this summation am into x power m. Okay, m equal to 0 to infinity. That is going to become like summation m equal to 0 to infinity minus 1 power m. Okay, minus 1 power m a0 divided by m factorial into x power m is going to come. So this one I can write the summation a0, I can take it out, summation m equal to 0 to infinity minus x power m, okay, divided by m factorial is going to come. This is nothing but a0 into e power minus x series. Okay, so same thing you can see that. Okay, same thing. Instead of c, there a0 is going to, that's all. So same thing is going to come here. Okay, so that's what I have. So m equal to 0 means a1 equal to minus a0 by 1 and etc. I don't know. Okay, so you can just have a look at this one, the slide. Same thing I have. Okay, fine. Now let us go to the next one. Okay, the next problem what I am going to have is that I am going to have this problem y dash minus 5y equal to 0. Okay, so if it is y dash minus 5y equal to 0, what I am going to have y dash minus 5y equal to 0. Therefore, this is going to become like dy by dy equal to minus plus 5 dx is going to come. Therefore, you are going to get ln x equal to 5x is going to come. Okay, So this is going to become like 5x. Therefore, you are going to get the plus c is going to come. Okay, c1, let us say. So this is going to become like c into e power 5x. So let us see whether this is going to be happening in this case also. So in this case, I can erase this one. Okay, y dash. So I'm going to have y dash minus 5y equal to. So this is going to become like minus 5am is going to come. Same kind of thing. Okay, minus 5am is going to come. So therefore, this is going to become like m plus 1 into minus 5am is going to be there. Therefore, am plus 1 is going to become like 5am divided by am plus 1 is going to be there. Therefore, in this case, your a1 is going to become like 5a0 is going to come. a2 is going to become like 5a1 is going to come. 5a1 by 2 is going to come. Therefore, this is going to become like 5 square a0 is going to come. Okay. And here once again, this is going to become like 5a2 by 3. Therefore, this is going to become like 5 cube into a0. Okay. Here again, it is going to become like a3 by 4. Therefore, this is going to become like 5 power 4 by a0. Okay. 5 power 4 by a0 is going to come. Therefore, here you can expect that this is going to become like 5 power m a0 by m factorial is going to come. Therefore, same kind of logic here. So this is going to become like 5 power m. Okay. And this is going to become like 5 x power m. Okay. This is going to become like 5x power m. So therefore, here you can expect that this is going to become like e power I5x is going to come. Okay. This is going to become like e power a0 into e power 5x. Okay. So you can verify that here also same thing. Okay. So you can see that m 5x power m into m factorial is there. So a0 into e power 5x is going to come. Now let us solve the third problem. Okay. The third problem is going to talk about 1 plus x into y dash. Okay. Instead of this one, we are going to have 1 plus x into y dash. So let us check what is the solution we are going to get. Okay. We are just solving some simple problems only. Later we will solve some complicated problems like legendary equation and Bessel's equation. So yx plus y dash equal to y is going to be there. Therefore, once again here you can see that dy by y equal to minus 1 by 1 plus x is going to come. Okay. Oh, sorry. 1 plus x y dash equal to y is there. Okay. 1 plus x dash. Okay. So 1 plus x y dash equal to y. Okay. Therefore, this is going to become like dy by y equal to dx by 1 plus x is going to come. Okay. Therefore, this is going to become like ln y equal to ln of x 1 plus x. Okay. Therefore, into c is going to come plus c1. Let us put. So this is going to become like c y equal to c1 c into 1 plus x is going to come. Okay. Let us check whether it is going to be there. Okay. So let us check here. So what I'm going to have? I'm just going to erase this because it is not going to be the same thing. We are going to get different relation here. So let me erase this. So 1 plus x into y dash is there. So I can write this as y dash plus xy dash minus y equal to 0. I can write it. Okay. So y dash I'm going to keep it like summation m equal to 0 to infinity m plus 1 into am plus 1 into x power m. Okay. And then I have the second term, I have to multiply by x, therefore I am going to multiply here. Therefore, this is going to become like summation m equal to 1 to infinity, not 0, m equal to 1 to infinity, m into am into x power m, plus here I am going to have a summation m equal to 1 to 0 to infinity, am into x power m is going to come. Okay, so this is the one I have. Okay, so therefore I can simplify this further. Sorry, minus y, therefore it is going to be minus. Okay, minus is there equal to 0. So I'm going to simplify this further. Okay, if I simplify this, what I'm going to have? I'm going to have summation m equal to 0 to infinity. Okay, I can put this also 0 to infinity. Okay, because here m is going to be there, therefore this term is going to vanish. So therefore I can put m equal to 0 to infinity. Therefore this is going to become like m plus 1 into am plus 1 plus m minus 1 into am into x power m equal to 0 is going to be there. I can't take x equal to 0, I can take only this one as 0. Therefore, this is going to be m plus 1 into am plus 1 plus m minus 1 into am equal to 0 is there. Therefore, it is going to become like am plus 1 equal to minus m minus 1 divided by m plus 1 divided by m plus 1 into am is going to be there. Okay. Divided by m plus 1 into am is going to be there. Therefore, what you are going to get is that you are going to get here, what you are going to get is that when m equal to 0, same thing. When m equal to 0, what it is going to come? M equal to 0 means this is going to become like a1. A1 is going to become like, I'm going to put m equal to 0, therefore this is going to become like minus, okay, 0, the minus is minus, this is going to come. So 1 by 1 is going to come, therefore it is going to become like a0 is going to come. Now m equal to 1, if I put m equal to 1, this is going to become like a2. A2 is going to become like 1 minus 1, 0 is going to be there. Now 0 is going to be there. Okay, m equal to 2, this is going to be in terms of a2. A2 is already 0, therefore a3 is also 0. Okay, so the remaining all going to become 0. Okay, am is going to become 0 when m is not equal to 0 and 1. Okay, this is going to be there. Therefore this is going to become, so in this case this is going to become like summation m equal to 0 to infinity. I'm going to have only two terms is going to be there. So first term is going to be there, second term is going to be there. Therefore you are going to get a0 plus a1 into x is going to be there. Okay, a0 plus a0 x, this is, okay, I can take a0 out, therefore this is going to be like a0 into 1 plus x is going to be. Okay, so next one, so you can observe that over here. So the next one, what I'm going to have is that I'm going to have the another problem, y dash equal to minus 2xy minus 3xy. Okay, so y dash equal to minus 2xy. So in this case, what you are going to have, again dy by y equal to minus 2x is there. Therefore, you are going to get ln y equal to minus x square. Okay, plus some constant is going to come. Therefore, y is going to become like c e power minus x square is going to come. Okay, let us see whether it is going to be there. So let me erase the rest. Okay, so this is going to be a little different. Okay, we have to deal it in a different way. Let us see that. So what I am going to have is that I am going to have y dash. Okay, I have y dash. Y dash is going to be y dash. I am going to use this one, summation. Okay, summation m equal to 1 to infinity m into am into x power m minus 1. Okay, I'm going to use this, or I can use the second one also. I'll just let me use the second one. Okay, m plus summation m equal to 0 to infinity m plus 1 into am plus 1 into x power m. Okay, plus I'm just going to bring this over here. Therefore, I'm going to get 2 into summation m equal to 0 to infinity am into x power m plus 1 is going to be equal to 0. So here what I'm going to do is that I'm going to separate the odd term and even term separately, because one I have x term and here I have x term plus 1. Okay, so suppose I have taken this term, let's say this is in terms of k. So suppose I take the term 2k minus 1. Okay, 2k minus 1. Suppose m equal to 2k minus 1. Or I just simply say that it is 2m minus 1. Okay, it's a k is a dummy variable, so I will just treat this with the 2m minus 1. So in that case, what I am going to have, this is going to become like, suppose if I write this one m equal to k minus 1, this is going to become like summation k equal to 0 to infinity. Okay, this is going to become like, I'm going to have okay. Now what I have to do, I have to compare the least coefficient. So the least coefficient is x power 2k minus 1 is there. So in this case, I have to take x power 2k minus 1 term here. Therefore, this is going to become like 2k into a2k is going to come. Okay, here I have to take, in this case, I have to take the previous term. Okay, not this term. I have to take one previous term. Therefore, this is going to become like plus 2 into a2k minus 2 is going to come. Okay, not 2k minus 1 I cannot take. I got to take one term previous, because here x power 2k minus 1, here it is x power 2k. So previous term is going to become like a2k minus 2 is going to come equal to 0. Therefore, what I am going to have, I am just going to replace this k by m again. So this is going to become like 2m into a2m plus 2 into a2m minus 2 equal to 0 is there. You can keep k itself if you don't have any problem of understanding, no problem. Okay, so this is going to become like a2m equal to 2 gets cancelled, so this is going to become like minus a2m minus 2 divided by m is going to come. Okay, this is going to be your a2m relation. Now a2m is in terms of a2m minus 2. Now second case what you are going to take is that I am going to take the even case m equal to 2k. If I put m equal to 2k, what it is going to come? This is going to become like summation k equal to, again I am going to put that k equal to summation k equal to 0 to infinity. This is going to become like 2k plus 1 into a2k plus 1 into x power 2k. Okay, plus this is going to become like 2 into summation k equal to 0 to infinity a2k into x power 2k plus 1 is going to be equal to 0. Okay, so once again I got to do the same kind of logic over here. So in this case, what I'm going to take, I'm going to take the powers over here. So therefore here I have to take, if I take a 2k plus 1, so this is going to become like 2k plus 1 into a 2k plus 1. Okay, the least coefficient is x power 2k. So here if I take least coefficient x power 2k, that is going to become like one term less. So that is going to become like plus 2 into a 2k minus 1 is going to come. Okay, a2 plus 2m plus 1 into a2m plus 1 plus 2 into a2m minus 1 equal to 0. I can write it. Okay, so now what I am going to have, I am going to see what is my a2m plus 1 is going to come. Okay, so what is going to be your first now what I'm going to have, I'm going to check what is the coefficient of this. Now we got to evaluate this one. Okay, how do we evaluate? We need to check that whether it is going to be existing or not. So now let us come to this point. Okay, let us concentrate on this one. So here what I have is that I have the, if I expand this one, this is going to become like, if we put m equal to 0, I'm going to get a1 into x power 0. So a1 is going to be there. Okay, and here there is m equal to 0. Therefore, you are going to get. Let us see this one. So a1 plus I'm going to have m equal to 1, therefore I'm going to get 2 into a2x, okay, plus 3 into a3x square, etc. is going to come in the first one. Whereas in the second one, I'm going to have a1, a0 into x is going to be there. Okay, a0 into x is going to be there. So m equal to 0, it is going to become a0 into x. Then I'm going to have a1 into x square is going to come, etc. is going to come. So if this is equal to 0, what I'm going to have, I'm going to have a1 equal to 0 is going to come. Okay, a1 equal to 0, because if I compare this one, the constant coefficient, I got to compare, there is no other constant coefficient, so a1 equal to 0. So if a1 equal to 0, you can see that if I put m equal to 0, this is going to become like, I'm not going to get this one. Okay, so what you are going to get is that you are going to get if I'm just keeping, okay, for example, if I want this relation for a minus 1 is not equal, not defined, so therefore what you can define is that you can define from m equal to 1. Okay, if I define from m equal to 1, so in that case, what I'm going to have, I'm going to have 2 into 1, therefore 2 plus 3 into, okay, so you can just see that 3 into a3 plus a1, okay, you can see from here also 3 into a3 plus a1 equal to 0. Therefore, a3 is equal to minus a1 is going to come by 3, but a1 is already 0, therefore a3 is going to become 0. Okay, similarly, a5 will become 0, a7 will become 0, a9 will become 0. Therefore, in general, what we are going to get is that you are going to get a2m plus 1 equal to 0 is going to come. Okay, a2m plus 1 equal to 0 is going to come. Okay, so that term is going to vanish. So that means this term is completely vanishing. Okay, the m equal to 2 term is completely vanishing. So I'm just going to remove this one. Okay, this term is completely vanishing, so I'm removing it. So therefore, what I'm coming only this relation. Okay, so that one I'm going to find what it is going to come. Okay, so a to m is there, minus 2 power m minus 2. Okay, so this is going to become like, I can check what is going to come. So suppose, so let us find that if I put m equal to 0, if I put m equal to 2 here, okay, because m equal to minus 0, I put minus 2 will come. So if I put m equal to 1, this will become like a0 is going to come. So if I put m equal to 1 here, okay, if I put m equal to 1 once again, we put m equal to 1, this is going to become like a2, okay, equal to minus a0 divided by m is there. Similarly, a4 is going to become like minus a2 by this is m is nothing but 1. Okay, this is going to be 1, and a4 m equal to 2. If I put m equal to 2, a4 is going to be like minus a2 by 2, which is nothing but minus 1 square into a0 by 2 into 1. Okay, m equal to 3 means this is going to become like a6. This is going to become like minus a3 minus a4. Okay, minus a4 by 3. Okay, which is equal to minus 1 cube a0 divided by 3 into 2 into 1. Similarly, a8 is going to come. Therefore, in general, what you are going to get is that you are going to get a2m is going to become like minus 1 power m a0 divided by m factorial is going to come. Okay, a2m is going to become like minus 1 power m a0 by m factorial is going to come. Therefore, once again, you can do the same kind of job what I did here. So, you are going to get summation m equal to 0 to infinity. Okay, so it is not am, it is going to become like a2m, but it doesn't matter. Okay, so you are going to get minus 1 power m a0 into m factorial. Here, very careful, we are dealing with 2m. Okay, therefore odd powers are vanishing, so here it should be x power 2m. Okay, don't put x power m, x power 2m should be there. Therefore, this is nothing but, if you see this series, okay, this one I can write as summation m equal to 0 to infinity minus x square power m divided by m factorial into a naught is going to come. I can take the a naught out, therefore this is going to come out. Therefore, this is nothing but a naught into e power minus x square. That's what I have here. Okay, c into e power minus x square.